I'm an Ennemcien. We have been studying natural radioactivity. Now, we know that there are three kinds of emissions. Alpha particle, which is the heaviest, nothing but the nucleus of helium atom. 4 units of mass and 2 units of charge. Then the next is beta particle, which are fast moving electrons originating from the nucleus. Then gamma radiations, which are purely electromagnetic radiations. Now you have to study, just to remember, there are two qualities. One is the relative ionizing power. Ionize means knock out electrons from a neutral atom. Of course, alpha particle will have the highest ionizing power because it is massive compared to other two emissions. Then comes beta particle. It is electron, high-speed electron. The least ionizing power will be possessed by gamma rays. The relative powers are expressed by these numbers. Alpha, if the ionizing power of alpha is 10,000, that of beta is only 100, and that of gamma is 1. Just to see the difference. Most highest ionizing power for alpha, then comes beta, then comes gamma. You try to remember these values. Penetrating power, power to penetrate into depth of matter. That is in the reverse order. The least penetrating power is possessed by alpha particle, then comes beta, and the highest penetrating power is for gamma rays, 10,000, 100, 1. Okay. Then, neutron. Neutron is electrically neutral. It is slightly heavier than proton. Inside a normal nucleus, it is stable. But outside the nucleus, it disintegrates into proton, electron, and an antineutrino. According to this scheme, say, neutron when it is outside the nucleus. Of course, in radioactive nucleus, the same decay process takes place. The decay process is like this. A neutron splits up into proton, beta particle, and an antineutrino. The lifespan or the mean life of a neutron when it is outside the nucleus is only 12 minutes. Within 12 minutes, it will disintegrate into proton, electron, and neutrino. Now, what is a neutrino? Neutrino is the nickname meaning little neutral particle. Little neutral particle. Neutral, little, not. Not means zero. Its rest mass is zero. It travels with the velocity of light. It is electrically neutral. At the same time, very little, small in size. So these terms, neutrino, the nickname of this combination, formed from this combination, neutral, little, not zero charge, little, because there is neutron. So the special name neutrino is given to this emissions. Neutrino, there are three forms of neutrino. One is associated with electron, another associated with the muon, that is an elementary particle, and another is associated with the tau particle. You need not know all about these things. Just you know that neutrino is an elementary particle of zero rest mass traveling at the speed of light. It has its own antiparticle known as antineutrino. That depends on the spin, difference in spin. These are things which you may not be familiar with. I do not go into deep depth of these things. Okay. Now there are three categories of neutron. One is fast neutron. Fast neutron means energy range is from 1 to, this is of the order of 1 million electron volt to 2 million electron volt. So neutrons possessing energy in the range 1 to 2 million electron volt are called fast electrons. Of course, these energy values are very small, but if you stand below a shower of these neutrons, you will be dead within an instant. That much powerful neutron shower. Then comes slow neutrons. Its energy is of the order of 1 electron volt. These are million electron volt. This is of the order of 1 electron volt. Neutrons possessing this energy are called slow neutrons. Then comes thermal neutrons. Its energy is of the order of 0.025 electron volt. Then we have to see of these three emissions, alpha, beta and gamma, only alpha particles travel in straight paths in dry air at atmospheric normal pressure. That is called a range. The distance traveled in straight line is called a range. In dry air at normal pressure, range of alpha particle is of the order of say 3 centimeter to 12 to 15 centimeter. And the range is directly proportional to cube of velocity of the alpha particle. Velocity of alpha particle depends on the parent nucleus from which it is emitted. Say from polonium to thorium, these ranges vary from 3 centimeter to about 12 centimeter or something like that. These are essentials about neutrino, neutron and gamma radiations. Now there comes another point. Pauli's theory of beta decay, beta disintegration. How does electron is emitted from the nucleus? That was an enigma because the observed value of energy possessed by beta particles emitted was found to be of a continuous nature, a continuous variation of energy, or beta particles of continuously varying energy are emitted from different nuclei. This continuity of energy could not be explained normally. So Pauli suggested a new theory. He predicted the existence of a new energy packet called neutrino. Neutrino was suggested by Pauli. According to him, when a radioactive nucleus is about to emit a beta particle, a neutron in the nucleus splits, disintegrates, as I said earlier, into a proton, electron and an antineutrino. It is this electron comes out of the nucleus along with this antineutrino. And this antineutrino and electron, they will share the energy between them so that a continuous sharing may take place, or sharing may take place in a continuous manner. There is no quantum nature in the sharing. They may share energy according to their own will. So the emitted beta particle can have any energy, maximum possessed by both. The energy of the entire energy of the neutrino may be shared by, accepted by the beta particle. So it will emit with highest energy. Or it may not receive energy from the neutrino. So it will emit with the least energy. Or it may share half of its energy and so on. So a continuous energy can be shared in a continuous manner. So according to Pauli, when a radioactive nucleus is about to emit a beta particle, a neutron in the nucleus disintegrates into a proton, electron, and an antineutrino. It is this electron that comes out along with the neutrino in the form of beta particle. And these beta particles are fast electrons, so that they will be slightly massive than the shell electrons, because shell electrons are of low speed compared to beta particles. According to Einstein's theory of relativity, as velocity increases, mass also increases. So beta particles are heavier, slightly heavier than shell electrons. The remaining proton during the disintegration will reside in the nucleus itself. That is why after beta emission, the atomic number of the nucleus is increased by 1, because a proton is created there by the disintegration of the neutron. So these are the essentials concerning the emission 3, radioactive emissions. Thank you a lot. We will discuss some problems. Thank you.